All right, hello students. In this video, we're going to look at the worksheet Exponential Growth and Decay Word Problems, which were pages 5 and 6 in the notes handout, okay? So once again, let me emphasize, we have y equals a, b to the x, and when it's growth, right, y equals a, b becomes 1 plus r. Remember, r has to be in decimal form, and if it's decay, b becomes 1 minus r. Okay? All right, the world population in 2000 was approximately 6.08 billion. So this is the initial amount. The annual rate of increase was about 1.26%. Okay, so this one is the rate. Find the growth factor. Once again, it's increasing. So it's going to be 1 plus r. The growth factor is b. When its growth is 1 plus r. So it's going to be 1 plus 1.26, right, divided by 100. So that gives us 0.0126. So 1.0126 is the growth rate. Yeah. Growth rate. It's the factor. Suppose the rate of increase continues to be 1.26%. That means nothing changes. Write a function to model the world population. All right, this function has to be in y equals ab. And since its growth is going to be y equals a, 1 plus r to the x, okay? So y equals a, which is the initial value, 6.08. And I'm writing in the wrong place, aren't I? Y equals 6.08. The factor is 1.0126, right? It's accounting for the growth, and then raised to the x. So that would be the model, the function model. Now, let x be the number of years past the year 2000. Find the world population in 2010. So if it started in 2000, 2010 is 10 years later. So that means that x equals 10. All right, and so we substitute it in. Just trying to make sure that we're still on camera. Heading over to decimals. 0.08. 0.0126 raised to the 10 years. There you go. I'm going to round that off to 6.89. So that means the population is going to be 6.89 billion. All right, so it started at 6.08 billion, and it's now 10 years later, it'll be 6.89 billion. All right, a computer valued at 6,500 depreciates at the rate of 14.3% per year. All right, so this is the initial value. Depreciates means decay, and that's our R, right? And if I turn this into a decimal, it's 0.143. Write a function that models the value of the computer. Right? Y equals, A is the initial value. Then it's 1 plus, is it growth? Nope, sorry. Oops, big mistake. I need my fancy eraser. Of course, I gotta use it properly. And I'm not editing this video, I better stop making mistakes. Why no work? There it is. All right, 1 minus 0.143. 0.143 raised to the x. And of course, you can work out 1 minus 0.143, right? 1 minus 0.143, and it's 0.857. So you can also write this as y equals 6,500, 0.857 raised to the x, okay? And both will be the same. Find the value of the computer after 3 years. So that means that x equals 3. So then y equals 6,500 0.857 raised to the 3. Okay. 857 raised to the 6. Let me see, what is this? 2575. It doesn't say anything about rounding, so we'll just leave it like this, okay? So the original value was $6,500, and it's now $2,575 after 3 years. So you've literally lost almost $4,000 in value, I would say. All right, so that's the value of the computer, the new value after 3 years. The population of a certain animal species decreases. So that tells you this is a decay problem at a rate of 3.5%. So R is equal to 0.035. You have counted 80 of the animals in the habitat you're studying. So this is the initial value. We have 80 animals. Write a function that models the change in the animal population. Remember we said it was decay. So y equals the initial value, 1 minus 0.035 raised to the x. All right, and if I simplify this 1 minus the rate, 1 minus 0.035, I get 0.965. Right? So this is the function that models. Either one of these is going to be the same thing. Graph the function, estimate the number of years until the population first drops below 15 animals. So when graphing this, right, it's going to be decay. All right, this right here will be 80. And you're looking for 15. To find it, you come down, and this right here will be the number of years that it'll take in order for the population to drop below 15 animals. Okie dokie. All right, so that was page 5. Let's look at page 6. Write an exponential function to model the situations. Find the value of each function after 5 years. All right, so x equals 5. 12,500. Car depreciates, decay 9%. Right, so this is A. This is decay. And R is 0.09. So here we go. Y equals 12,500. Decay 1 minus 0.09 raised to the 5. Okay. So using a calculator, 12, 1 minus 0.09 raised to the 5. 7,800.40. So it looks after 5 years, the car is only going to be worth $7,800. All right, a baseball card bought for $50, that's the initial value, increases at 3% each year. Okay, so then y equals 50 decreases, no, increases. So this is growth. Oh, I almost read that wrong. Increases. So it's 1 plus 0.03. And x is what? 5 years. We say right here, x equals 5. Okay. So then put it in decimals. It's going to be 50. 1 plus 0.03 raised to the 5. $57.96. There you go. So your $50 card, baseball card, my brother used to collect baseball cards, increases 3% in value each year. A new car that sells for $18,000 depreciates 25% each year. Write a function that models the value of the car and then find the value of the car after 4 years. New car. This is the initial value. All right, so this is A. Depreciates means decay. 25% means R equals 0.25. All right, writing the function, y equals 18,000, 1 minus 0.25. Right, and if you simplify that, it would be 0.75 raised to the x. Find the value of the car after 4 years. All right, so that means x equals 4. So after 4 years, okay. Oh no, did my computer freeze? 18,000.75 raised to the 4. Ooh, what is this? Oh, this is horrible. What kind of car is this that loses its value so much? Look at that. You bought it for $18,000 and then 4 years later, oh wow. It's like a quarter of the price. Can't even sell it for $6,000. Oh well. A new truck that sells for $2,900 depreciates means decay 12% each year. Write the function y equals initial value. It is decay, so it's 1 minus the rate 0.12. All right, so that's the function. And I'll write it different ways because if it's multiple choice, you never really know how they're going to present the information. So 1 minus 0.12, 0.88. So they might show it like this, 0.88 raised to the x. Either one of them is the same thing, but find the value of the truck after 7 years. Stop moving, stop moving. Oops, sorry, 29,000, 0.88 raised to the 7. Look at that, 11,851.59 cents. So this truck originally was 29,000, and after 7 years, it is close to 12,000. That means if you sell it, you're only going to make 12,000 of the 29,000. All right, the bear population increases at a rate of 2% per year. Increases means growth. There are 1,573 bears this year. Write a function that models the bear population. Y equals initial value. Its growth of its 1 plus. All right, once again, you might see it like that, or you might see it like this. Okay. How many bears will there be in 10 years? All right, so 1573, 0.02, raised to the 10. Ooh, 1917.78223. All right, we're going to round to the nearest ones because we can't have part of a bear, right? So that would be 9, because of this 4, it's 1917. So we can expect, if it continues growing at 2% per year, we can expect in 10 years to have 1,917 bears from the 1,573 bears that we used to have. Not bad, right? All right, so I hope you enjoyed writing the function and solving growth and decay problems.